Huffman coding algorithm. It is a lossless compression algorithm. So I'm going to explain how to encode a message. So only two steps are sufficient to understand this Huffman coding algorithm. We will take one example. Five symbols S0, S1, S2, S3, S4 of a source have the probability zero point 0.4, zero point 0.2, zero point 0.2, zero point 0.1 and zero point 0.1 respectively. Find the code word using Huffman's algorithm. Yeah. So we'll prepare one table such that the probability should be arranged in a decreasing manner. For example, in this case, it is already in a decreasing a zero point 0.4, zero point 0.2, zero point 0.2, zero point 0.1 and zero point 0.1. Yeah. Yeah. S0, S1, S0, S1, S2, S3, S4 have a probability of zero point 0.4, zero point 0.2, zero point 0.2, zero point 0.1 and zero point 0.1. So this is the first column is a symbol and second column its corresponding probability. Yeah. So from the bottom side, okay, we have to group these two probabilities. Yeah, in this case, S3, S4, its corresponding probabilities 0.1 and zero point 0.1. These two are added and its probability is 0.2. So we have probability of 0.4, 0.2, 0.2. So this 0.2, that we have to place it in a higher position. So we have already 0.2, 0.2. So this should be kept above these two. 0.4, 0.2, 0.2, 0.2. Again, and also assign a symbol for these two. That is a 0 and 1. Upper side it is 0, lower side it is a 1. So next, this 0.2 and these 2 points, these are in a lower position. These two are added and 0.2, 0.4. Already we have a 0.4 here and this will be kept above this 0.4. 0.4 and this 0.4 comes here and this 0.2 it is moved here. Again, these two and also coded with a 0 and 1. So this is 0 and 1. Next, 0.4 and 0.2. When we add these two, it is a 0.6 and code it is a 0, 1. The last step is, and this 0.6 is assigned a 0 and 0.4 is assigned a 1. Yes, okay, very simple here. So these two probabilities are added and we have a probability here 0.4, 0.2 and these two and this one is same, but this should be kept as high as possible. Yeah, it comes here. Then 0.2, 0.2 and assigned a 0 and 1 here. 0.2, 0.2, it is a 0.4, its probability and we have a 0.4, this kept above this 0.4, 0.4 and this 0.4 comes here and this 0.2 is moved here. And again 0.4, 0.2, it is a 0.6 and coded with a 0 and 1. Upper is 0, lower is 1. And similarly 0 and 1. Next step. Already we have 0, 1, 0, 1, 0, 1 and 0. So first we will complete where we combine the probabilities here. So in this case, this 0.4 and 0.2 are combined and have a symbols like 0 and 1. And what about this output where it goes? It goes to the 0.6. And what is the code it is assigned here? It is a 0. So append these two. So 0 at the this upper side and 0 for this lower side. Okay, means 0, 0, 0, 1. Now this stage is. Then after that, this 0.4, yeah, this is comes from adding these two probabilities 0.2, 0.2. Where it goes, it is a 1 here and already it has a 0 and 1. This 1 comes here. So append this 1, this 1, 0.4, this one is appended here, 1, 1. Yeah. So next step, this is a probability 0.1, 0.1 we added and have a coded 0 and 1. So this will goes to 0.2 and this code has a 0, 1. Means we have to append this 0, 1 to earlier already we have a 0 means 0, 1, 0, 0, 1, 1. Yeah. Now what will be the code for S0, S1, S2? Now S0, for example, in this case it is a 0.4, 0.4, 0.4. So what is the code here? 0, 0. Next point 2, what is the code? 10. Point 2, here point 2, 1, 1. And point 1, 0, 1, 0, point 1, 0, 1. In this, we can code. And also, we will prepare a table such that symbols and corresponding probability and code word and its length. Now we will determine the average code word length. L bar is P1, L1 means probability of this L1. For example, zero point 0.4 code word are 2. Zero point 0.4 into zero point 0.4 into 2. Next is a 0.2, its word is 2. Similarly, 0.1 into 3, the last one, 0.1 into 3. The simplified answer is 2.2 binary symbols. Next, the entropy is a summation of a pi log base to 1 by pi. Uh, in this case, probability is zero point 0.4 log base to 0.4, 0.2 log base to 0.2. Similarly, so other steps. The last one is a 0.1. This will be a 2.121. And efficiency is entropy divided by average code length. That is a 2.121, 2. It is a 96.4%.